Today, I'm excited to present our project deploying an LLM chatbot application using Docker. This project was a team effort. I worked alongside my classmates Mahita and Yashaswini.
Hello, I'm Yashaswini.
And I'm Mahita.
Introduction. LLMs are revolutionary, but deploying them is tough due to complex dependencies and resource management. Our solution is Docker. Packages the app and its dependencies into a lightweight portable container, eliminating environment inconsistencies. Our project is a document Q&A app that combines cutting-edge tools like Radio for UI, Label Index for pipeline, Mixspread AI, and Grok Cloud for fast interface. The result is an easy, scrappable, shareable chatbot deployed on Hugging Face spaces. Our aim. Our primary goal was to successfully deploy a document Q&A LLM application using the Docker to ensure portability and easy cloud deployment. We implement a revival argument generation RAG pipeline LAML with a LAML index to make sure the LLM responses are context aware, based specifically on the uploaded document. We focused on LLM OPS practices, isolated dependencies, and created a reproducible workflow from our local machine to the cloud. Objectives. We set out to build a document Q&A application where users can upload a file and ask questions about its content. We successfully integrated multiple AI services into one seamless pipeline. We have completely containerized the app using Docker so it runs reliably anywhere. Crucially, we optimize the Docker image by offloading heavy AI tasks like the large LLM external services to keep our image small and build tags faster. Tools and techniques. The tech stack. We used Gradio blocks for the interactive user interface, allowing file uploads and chat. The RAG pipeline was orchestrated by the Label Index. The key services integrated were Label Cloud for the parsing files, Mixed-Bread AI for the converting documents into embedding, and Grok Cloud for extremely fast LLM responses using the Label 3.17b 70b model. Finally, Docker encapsulates everything, and with Hugging Face Cloud handling the final deployment. Methods and methodology. The architecture, we adopted a closed source integration approach combining multiple API services, which allowed us to achieve faster development, keeping our Docker image size small. The flowchart starts when a user uploads a file and enters a question into the Grado UI. The document goes through the file phraser, Label Cloud, and is turned into embedding by the embedding model, Mixed-Bread AI. The label index RAG pipeline performs a revival from the vector store to get the relevant context. This context is sent to the Grok LLM to generate a fast, context-aware answer that streams back to the user. All these components, including the API and dependencies, are managed by Docker. Objective 1. Setting up the environment. We start by installing Docker and creating the project structure in VS Code. We secure our API keys for Label Cloud, Grok, and Mixed Breed AI in a env file to ensure we they are handled securely during deployment. Objective 2. Building the LLM application. We developed the app.py script, which is the heart of the RAG pipeline, integrating all the cloud services through Label Index and setting up the Grago UI. Objective 3. The Docker file is a container's blueprint. It uses a Python 3.9 Slim base image, setting the work directory, copies and installs the requirement, copies the application code, exposes the Grogo port 7860, and finally runs the Python app.py. Objective 4, running the container. We built the image using the Docker build -d doc QA and ran the container locally, mapping the port and loading the environment variables securely from the env file. Objective 5, deploying the Hugging Face. By committing our files, Hugging Face automatically built the image using our Docker file and deploying it. The final image shows the application successfully querying a PDF, calculating a tax deduction, and finding the total amount all within the containerized environment. Conclusion. We achieved a successful end-to-end deployment of the Dockerized LLM app, the full parsing, embedding, revival, and interface workflow. The main success is reproducibility and portability. The environment is identical locally on Hugging Face spaces. Our optimizations were effective, image sizes were reduced by about 40%, and LLM response latency dropped significantly. For future, we plan to implement CI/CD for automated updates and exploring migrating to a private stack for better data privacy.
Hello, I'm Yashaswini, and I'm going to walk you through the code execution of this project. So we set up our entire project environment in VS Code. The main project file is the app.py. So the first part that we can see is we imported all of the required packages. The most important ones are Gradio, Llama Index, and path.pathlib. So this section of the code is a monkey patch for the Gradio client schema bug. Since we're using a deprecated version of Gradio, this is essential to make sure that our app does not crash when we're trying to run it either through the command line or through Docker. Next, we load the environment file, which contains all the API keys. For the purposes of this demonstration, the API keys have been hidden out, but we took the API keys from Llama Cloud, Grok, and Mixed-Bread. Llama Cloud and Grok API keys will be used to access the AI models that will be used to query the chatbot, and then Mixed-Bread AI API key will be used to keep track of the embeddings and the tokens that we're using for each chat. The Llama model that we're using is Llama 3.370B versatile, and the embedding model, that is the Mixed-Bread AI model, is the Mixed-Bread Embed Large V1 version. Next, this part of the code shows all of the parsers that we're using. This is to make sure that the chatbot is able to extract and read through any kind of file, whether that's a PDF file, a Word document, an Excel sheet, an image, or a regular HTML website. We're then holding our embedding model in this variable by using a function from the Mixed-Bread AI embedding that we imported earlier. And then the LLM will be stored with the Grok model that we defined here. Now, the rest of the functions from here on out, these three are the helpers. So these are basically going to help us and help Gradio set up the UI and make sure that all of our file inputs are passed correctly without any excess data that is being used. Here we're defining the user and the assistant. The user will be the person interacting with the chatbot, and then the assistant will be the model working behind the scenes to provide an output. Next, we have two functions that we're implementing, the load files function and the response single function. The main functionality of the load files is to basically make sure that when the user is submitting the file, it is submitted without any errors. It calls the embedding model and also create a vector index using the embedding model, that is a Mixed-Bread AI. So here we can see that the documents are being passed using the input files command. The vector indexes are being computed and stored in this variable. And then the file name is also stored using the OS package that we imported. This exception block will make sure that if the file is corrupted by any chance, then it'll throw an exception and ask us to re-input the file. The response single function is basically an assistant string. This is the output message that we get once the file is uploaded. If the file is uploaded, then we will get the response. But if it's not, then it'll print the debug statement with the type of error that there is. And if the user by mistake tries to interact with the chatbot without uploading a document, it'll provide a print statement to ask the user to upload a document first. Next is a clear state function. The clear state function here makes sure that the state is clean, that is, the history is cleaned after every session. This is to ensure that because we are using public API keys and a public free model, there are certain API limits, and to ensure that when we are testing this project, we do not over exceed the API rate limit. The clear state function will make sure after every session, the history is erased and the model can again run for another session. The submit and append session kind of works like a regular messaging apps. So the input here will be a message that is in form of a string. It will also consider the history within that session. So whatever the output the previous message gave, and then the output will be the text that is displayed. That is the response that the assistant gives. So here we can see that the answer is being computed from the respond function. The history is then being updated to contain all of the previous answers, and the text is being displayed by using the function history to display. The exception block is again used to make sure that if there is any error, instead of crashing the entire app, it'll just print an error to check the server logs. The next part of the code is defining the Gradio UI. So this is basically the HTML part for uh, launching the Gradio app. As seen in the PPT slide, we can see the final interface has a block for submitting the file. It has a block for showing the assistant's output, and it has a block for the user entering the input. So we can see this defined here. Next, we hook up the main events to the Gradio interface. We have a button to send the input. We have a button to upload the file, and we have a button to check the status of the file. This final statement in the Python code launches the app so that it is usable on the local host. We can see the output in this command prompt here. So here we run the python app.py, and then it gives us two links where we can run it on. This is the Gradio link, and this is the local host link that will run as long as the session is available. Next, we have the Docker file. This Docker file is mainly used to create the Docker container and the Docker image, which can be seen in the output here. So this is the command to build the Docker image. And then once the Docker image is built, we can run the Docker container, which will be continuing as long as the session runs. So this is the Docker image that was created, doc.qa. We can see that all the apps and the environment variables have been uploaded. And this is the container that will be active.
I'm Mahita, and I'll be discussing the features of the final output. Once we launch the Docker container, it produces us with a link which takes us to the website. Okay, this is the final output that we get once we open the link provided by Docker container. We used Hugging Face interface to enable seamless integration. Here we can see in the URL, this is the link that we pasted, which was given by the Docker container. So from here, you can see the features of the whole website. Here on the left side, we have the file upload option. Once we upload a file here, we can start the conversation with the chatbot. Until and unless you upload a file, you're gonna get an error message. And here we have the question card, where we can start the conversation and ask the main questions that we want from the document that we've uploaded. Once we enter a question, it is displayed in the conversation card, where you can see your questions as well as the chatbot's replies. So let's take a demo of this website. Let's click on the upload file and let's upload a simple file. Yes, here I've uploaded the event proposal file, which is a simple simple PDF file with just text. Here we can see the status of the file, which is it's ready to give responses on. If we upload an invalid file, we're going to get a different error message that it's not ready. So since we've already uploaded a file, which is an event proposal simple PDF file consisting of only text, let's now ask it a simple question to start with. Let's ask, what is this event about? Once we hit the send, we can see our question in the conversation. We are labeled as user, and the assistant is the chatbot. The chatbot is now replying us with the answer about a summary of what the event is from the content that it takes from the PDF file. So as we can see, it says retro reboot gaming competition, which is the accurate description of the event, as we've seen in the title of the file. Now, if you want, we can ask more questions as well, but it's going to be limited to the content that we give. Let's ask, what is the date of the event that they're planning? Once again, when we click send, we can see the previous history as well. And we can see the answer that it's on 22nd October, which is accurate. So this is how our chatbot basically works. We can upload the file we want a summary about, which can be any kind of text file that you want. It can be your daily class notes too. And we can ask it questions that we want to know about the file. So this is our whole interface and our chatbot that we've built. This is our project on deploying an LLM using Docker. Thank you.